Welcome to this session on the PowerPack for Advanced Steel from Graitec. And we're taking a look at the create macros, in particular stairs. And in this instance, we're looking at a two-flight stair with an L-shape arrangement. So we're in Advanced Steel and we're just taking a look at the stair macros. In particular, we're going to focus upon using a two-flight L-form stair. And this comes as part of the PowerPack from Graitec for Advanced Steel under our Stairs and Railings module. Here within the two-flight L-form stair, you'll see an image in the dialog and also below in the text field some explanation of the various turn points that you need to use to create the stair using some basic geometry. So for the purposes of the demonstration today, I've actually created some primary geometry in 2D to show the overall layout of the stair, so the stair width, the goings between each stair here, each flight and each tread, and then similarly the rise and going shown actually in the vertical plane as well, represented by this magenta line. Also, I'm showing the various turn points or start and end points using these green circles and text fields. Also, some primary dimensions are shown here to make it easier to reference them into the various dialog fields that we need to discuss later on. These two values here will play particular importance in how you set the stair out. Also, the overlap of the stair is actually to do with the tread. Typically within a stair construction, you'd have an overlap value required, and in that case you need to select a particular setting, and this value is applied at the end of the stair construction. In this case it's 2 flights. If it was 3 flights, it would be at the end of the 3-flight stair. This overlap also influences the final position that you would select for the height of the stair at the top of this red line here. It's not actually the nosing point, it's actually the point beyond that defined by the overlap. So the easiest way to actually show this is actually to walk through the actual use of the macro. So following the prompts on the screen at the command line or via the dynamic entry, you would select point 1, which is the start of the stair. Following the magenta line along here, we come to the first turn point of the stair, which is point 2 in this case. Selecting that, obviously the prompt then changes to point 3. If you had more than 2 flights, you may have another turn point to select. In this case, I'm selecting point 3 here, representing the end of the base of the stair, and that is actually at the overlap position. So I've added in my overlap value there. My next point is the overall height, and I'm picking the point at the top of the overlap position here. So that's my point 4. I'm now prompted to select the bias position of the stair. Now, because I set out on the center line of the stair using that magenta setting outline, I'm going to select 1 from the command dialog by typing it in and pressing enter. This will now set the stair out about the center line that we had just used to create the turn points and the overall height point of the stair, including the overlap in this arrangement. So as that appears on the screen, we can see that it's obviously created a stair form. It may not be correct because we need to start setting some of the parameters and values in here. So if we come in here, the first field we would come to is tread, and then sub-tab layout, and we would select going and overlap. So adjusting that field in there, it will adjust the stair. Similarly, we would then come to the sub-tab dimensions and just check the tread overlap OV value here, in this case being 30 millimeters, which is the default. And that is the value that I've used in my stair construction for today. We would now change to the definition tab. And under here, we would come to the geometry field. And this is how you set the stair out around the landing area. So we have a landing value of 1500 millimeters to the turn point on the stair on actually both sides of the staircase. But that's not the value that we need to put in. The value we need to look at is actually the landing extension minimum value, which in this case is from the toe point of the stair to the inside point of the stringer of the stair. So hence these blue lines here, which indicate the width of the stair. The width of the stair is a meter, so they're 500 mil biased towards the inside. Obviously that's giving me these meter values here that I see for the value LE min. And that is effective on both the first flight and the second flight. You will see the value here. These are user-defined fields, and they actually influence the flight length field, which you'll see up here. So remaining with the first flight here, let's enter a meter into this value here. So in that cell, we're entering that. That's now going to change the form of the stair. And similarly, we would need to do the same thing on the corresponding field for flight 2. So entering those values in there, you can see that the form of the stair has changed again. We would now change to the ergonomics tab. Within that, we can still see that the form of the stair is not correct, obviously because the number of risers that we've chosen to use, in this case to meet the criteria that we need to do for the maximum minimums within our allowable stride measurements, which come from country standards. So in this case, we've got 9 goings. So I'm actually trying to achieve a rise of 180 millimeters in the vertical and a going of 250 millimeters in horizontal. And at the moment, we can see by the automatic calculation that is not correct. If we uncheck the automatic fit field here, this checkbox, you'll find these fields become active below. You can increase the number of treads or decrease by using the up and down arrows in the field, or you can type a value within the field cell itself. This will now adjust the form of the stair. We can now see that the rise and going has come to 180, 250, so the stair is now correctly created, and it follows the magenta toe line that I drew in to show that representation before I started creating the stair. We can also see that the overlap value has been applied obviously at the first flight level here for this last tread is at the overlap position. And similarly, obviously, where we're starting the next flight, we can see there's an overlap there of 30, but the toe is in the correct place following the toe position that we required here. And importantly here, if we were to come in and turn the landing element on, so if we come to the top landing element here and enable that, we will see the top toe of the stair flight, which is actually the landing toe as well, and that will appear, and that is formed in the correct place, with obviously the overlap value here for this tread matching the red line that we'd indicated before, and we'd use to create our 0.4 for the height and the overlap position based upon 0.3 down here. Similarly, just to pop back to the ergonomics tab here, you'll see that we can also check that within here we have the constraints that we've set based upon our country standards and how these fall within where the angle of the stair is being created. So we're in the green zone here, that's the good zone. And obviously the graph here shows us how it fits within those maximum and minimum dimensions used for the stride calculation, typical value based upon this formula here below. So that's a quick introduction to how to create a basic 2-flight stair in an L form. This will also enable you to follow this through if you wish to do U-flight stairs, 2 flights with a Z as well, and even our 3-flight stair arrangements. The important thing to remember is that you have an overlap value here, add it to the end of the overall base distance, not at the individual flight turns, but at the overall point here, which may be 0.3 or 0.4, maybe 0.5, depending on which form of stair you are choosing to construct. Thank you for watching this short introduction to the use of the Graitec Stair macro, which comes as part of the PowerPack for advanced steel.